Hi dear students, good morning. This is your Shallam Sai Krishna. Welcome to our online classes. Remaining concept of the chapter we have to discuss in this class. In the last class, we already concluded that Newton's first law of motion. In this class, we have to discuss about that Newton's second law of motion and Newton's third law of motion and its application in our everyday life. What we discussed in the previous class of Newton's first law of motion. Any object, whatever it may be, without applying of any external force, this object always in the rest position, otherwise in the uniform motion. Yes, there is no any external force. If it is in the rest position, mean always it is in the rest position. If it is in the uniform motion, mean always it should be in the uniform motion. It is according to the Newton's first law of motion. And about that inertia also we discussed as a clear. Yes, rest, motion and direction. Three types of the inertia about also we discussed. That inertia completely depends on the mass of the object. If the mass of the object is more, inertia also more. Yes, that also we discuss rest, motion, direction. Three types of the inertia about also we discuss as a clear. In this class, let us start about that Newton's second law of motion. What is meant by the Newton's second law of motion? This is an object, whatever it may be, this is an object. Yes, in the Newton's first law of motion, there is no external force I mentioned. But here, if it is there some of the any external force on any object, what will be happen? Yes, if it is there any external force on the any object, at the time what will happen? At the time object position will be changed. If it is in the rest position, when you apply any external force on that object, it should be comes into the motion. Yes, it should be comes into the motion. But in the Newton's first law of motion, if the object is in the rest position, always in the rest position. But here you are applying some external force on any object. At that time, what happening here? This rest position object should be comes into the motion. Suppose if any object, if it is in the uniform motion, which motion? If it is in the uniform motion, at that time this object should be comes into the non-uniform motion, otherwise the uniform motion will be changed. Yes, simply we have to keep in the mind, yes, if it is any object in the uniform motion, if you apply any external force on that object, at the time what will happen? Maybe its uniform motion position will be changed. Maybe it comes into the other motion, whatever it may be, like non-uniform motion. That's mean position of the object, state of the object will be changed when it is in the presence of the any external force according to the Newton's second law of motion. Newton's second law of motion. Yes, according to the Newton's second law of motion, the popular equation F is equal to ma. We should discuss and we should derive about this F is equal to ma. F mean force, F mean force, M mean mass, A mean acceleration. What is that? Acceleration. F is equal to M, a most popular equation. F mean force, M mean mass, A mean acceleration. What is that? Acceleration. Mass into acceleration, that is equal to what? Force. Yes. Here again one of the concept also we have to discuss here about that linear momentum. What about that linear momentum? Yes. What is meant by the linear momentum? P that is equal to mv. P that is equal to what? mv. P mean momentum. Yes. M mean mass. V mean velocity. Yes. Mass into velocity. What is that? Mass into velocity. P that is equal to m into v. Mass into velocity. Yes. is by these two we have to get that linear momentum. What is that? Linear momentum is mass kilograms, velocity meter per second, displacement by time. As we already discussed in the motion chapter, displacement by time nothing but what? Velocity, kg meter per second. The units of the linear momentum is kg meter per second. Here just we have to discuss about some of the example of the P that is equal to m into v, and some kind of the general examples of our daily life also we have to discuss about these. Suppose m value is more, x object is here, y object is here. Yes, x object m value is more and y object m value is less. Yes, which can show the more effect at that situation. Mass of the object is one object of x is more than y object. Sir. At the time what will be happen? Sir. Let us see. Simply, here it is one of the wall of our house. One of the wall of our house. Yes, here is one of the bus. Yes, again one only bicycle is here. Yes, it is moving with 10 meter per second. Yes, it's also 10 meter per second. In 1 second it is moving with 10 meters. It is also moving with 10 meters per second. Both velocity also same. Yes, what is that? Bus and cycle, both velocities are also same, but its mass is more than this bicycle. It should be come and dash this wall. At which situation the wall will be break? Simply we can tell this by the time, by the using of the bus only, the wall should be break. The wall should be break. Yes, because of the velocities both also same, but mass of this bus is more than this bicycle. That also we have to keep in the mind, because of the mass can be changed, the action of that object only. Again one point. Yes, I have one gun and one bullet. Now the bullet is outside of the gun. Simply I am throwing with some speed, maybe 10 meters per second speed with only I am just throwing. Yes, will it enter into your body? Yes, no, it will not enter into the body. Next situation, that is bullet only we are keeping in the gun and shooting from here. At the situation what will happen? At the situation that bullet will be enter into our body. Sir, in the second situation, why the bullet is entering into our body? Same bullet, mass of that bullet is constant. Mass of the bullet will be constant. Yes, one bullet only, one only outside of the gun, again one only inside of the gun. In this situation, velocity is less. Velocity is less, mass is same. Here second situation, velocity is more. Velocity is more. Due to the more velocity, the bullet is enter into our body. Bullet is enter into our body. In this situation, when the bus is dashing this one, at the situation what happened is the wall was broken. Is here in this second situation, when it is come with more velocity, high velocity, at that situation only it is only enter into our body. That also we have to try to keep in the mind. Next some concept, here one object is here, here one object is here. It is only 10 kilogram of the weight, it is only 100 kilogram of the weight only. Yes, here we are applying the 5 newtons of force. What is that? 5 newtons of force. Here we are also applying the 10 newtons of the force. Sorry, here also we are applying 5 newtons. Same force only we are applying. Here 5 newtons, here 5 newtons. Which object can be moved? Yes. Which object can be moved? Only this A and B. A object can be moved. Which object can be moved? A object can be moved because of mass of this object is less. Because of we are applying the same force of 5 newtons, so 5 newtons same force only we are applying here, but mass of this A and B object, A object mass is less than B object. So a object will be comes into the motion. That means acceleration will be more. Its acceleration will be more. Next situation we have to take here x, y both also 10 kilograms and 10 kilograms. Here applying force is 100 newtons. Here applying force is 10 newtons. Yes. Mass of the objects are constant. Mass of the objects are constant. But here what happened? We are applying that 100 newtons of the force on this object at the time. Here 10 newtons of the force on this object at the time. Which acceleration will be more? Yes. Absolutely, this x object acceleration will be more because of here these two objects also in the constant mass. They have the constant mass. But here applying force on the x object is 100 newtons. It is greater than the 10 newtons which is working on the y object. Due to that only this x object acceleration will be more. Yes, like this, so many different kinds of the examples there is a chance to ask in the examination. We have to try to remember of these kind of the examples. Next one, Newton's third law of motion. Yes, what is meant by the Newton third law of motion? According to the Newton third law of motion, on the two objects there is a working, the two forces are equally and in opposite direction. Equally and opposite direction. That we have to know as a Newton's third law of motion. Any two objects, whatever it may be, you have to take. On the two objects, how many forces are working? Two forces are working. Two forces are working as a equally and in opposite direction. This is a Newton third law of motion. There is an action and opposite reaction. There is an action and opposite reaction. Newton third law of motion. Newton third law of motion. Yes, Newton third law of motion. Yes, it is in a one object. It is in a one object. It is an x. It is in a y. This x is applying some force on the y, maybe 10 newtons of the force it is applying. Again, y also applying 10 newtons of the force only, but it is in the opposite direction. This is called Newton third law of motion. Yes, what are the applications of the Newton third law of motion? Simply we are walking, running. How it is possible? Newton third law of motion. While we walking on the floor, our legs are applying some force on the floor. Again, floor also applying same force on our foot in the opposite direction. Due to that only we are walking, we are running. Yes, birds are flying, swimming, whatever it may be. These all those things are the examples of Newton third law of motion. Newton third law of motion. Simply we have to keep in the mind, without Newton third law of motion we can't walk, we can't run, the birds can't fly, yes, the animals can't swim. These all those things also working on basis of the Newton third law of motion. The rocket is launching is from rocket station. At that time also there is a working of the Newton third law of motion only. Because of there is an applying the first force on the earth. As usual, earth also applying same force on the rocket in the opposite direction. Due to that only rocket will be entering into the space with a high velocity. Here also working the Newton's third law of motion. Not only these examples, any example also you should be applying to the another way only. Yes, you have to make that one balloon. First of all, you have to take that one balloon and you have to try to fill the balloon with some amount of the air and try to leave that. Yes, at that situation what will happen? The balloon will be moving at a certain distance. How it is possible? Yes, when you leave the balloon, what air is present inside, that should be combined applying some force on the atmosphere. As usual, atmosphere also try to apply some force on the balloon, Due to that only the balloon will be moved certain distance according to the Newton's third law of motion. Just you have to try to throw the one ball onto the wall. At that situation, what will be happen? How much amount of the force we are applying on the ball, same amount also applied by that wall. Due to that only the ball will be come back with the same velocity according to the Newton's third law of motion. Up to now, we simply concluded that Newton first law of motion, Newton second law of motion, Newton third law of motion. In the next class, we have to discuss about that impulse and we have to derive the equation F is equal to ma. Thank you so much.